All right, so we are going to continue. As I said earlier, hopefully this writing pad works now. All right, seems to be working. We're going to talk a little bit more about parallelograms, okay? And three specific ones are rectangles, rhombi, or rhombus. Why did I put rhombi? Why didn't I put rhombus? Yeah, because these are all plural, right? Rectangles, squares, and the plural of rhombus, it's not rhombuses, it's rhombi. All right, so that's why they put that. So we're going to talk about some specific things. So hopefully this pen will work now, as long as I don't mess around with it. I'm not going to write it down. I'm just going to show you a picture. And I think the picture describing it, to me anyway, I think that says more than just writing down the actual theorem in words. Do you think? Mm-hmm. But here it is. So this is a rectangle. So what am I missing, though, if it's a rectangle? The 90-degree angles. Okay, so if I do this, 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 and this, now it's a rectangle, isn't it? And these are what? These little cross-section things. What do we call those? Starts with a D? They're diagonals. They're diagonals, okay? Now, here's something. Let's just do this. It'd be easier if I did this. All right? The theorem says this. It's really simple. It says the diagonals of a rectangle are congruent. You hear that? Pretty easy. So here's the diagonals, and they're congruent, which means they're equal to each other, right? Equal to each other in length. So if I wanted to write some stuff down here to talk about that theorem, what would I say? So give me one diagonal here. Name the diagonal for me. BD is one, AC is the other one, okay? Those are the only two. All right, so what can I say? I could say that AC is what? If the diagonals are equal to each other, if the diagonals are congruent, what must be true? AC must be equal to what? To BD. Very good. All right. So AC, this diagonal right here, is equal to this diagonal right here. Everybody with me? We also, what else did we learn about diagonals of a parallelogram? They bisect each other, right? So this isn't the exact example that they give you. I'm going to give you a simple example before I give you an example that's maybe a little bit tougher, okay? So what if, I'll just make that a 5. What if that was a 5? We'll call this x in the middle, okay? So what if bx was equal to 5? Could you tell me the other segments of the diagonal, or could you tell me the whole diagonal? Let's do that. Let's find AC and let's find BD. Now that you know that the diagonals are congruent to each other, you also know the diagonals bisect each other. So tell me what AC is actually equal to, or BD. It's 10, right? Because BD has got to be 10, because this is 5, then what's this one? 5. And why is that? Because the diagonals do what? They bisect each other, okay? Now, this is the new part. That's old right there. Okay, that part is old. This is the new part. What's the whole entire BD? It's 10, isn't it? So what should that equal? That should equal what? AC. And so what must AC be equal to? That must be 10 as well. So that means, what is AX then? That has to be 5, and this has to be 5. Now this is only true on a what? This is only true on a rectangle. All right? Well, square is a rectangle, but you're absolutely right. It's a good point. Okay, so it is true about a square as well, but remember, a square is a rectangle, right? Because it's a quadrilateral with 4 right angles. But you're absolutely right. This would be true about a square. Okay? Now, there's other things. No, he was saying that because he did watch them, and he's answering, so that's good. All right, let's do the example they have in the book. That was a super easy one, just putting a number in there. But that's pretty easy to understand, isn't it? All right. But you know what they're going to do. Take a wild guess what they're going to do without even looking. Yeah, but how do they make it harder? What are they going to put in here? Yeah, they're going to stick some letters in there. Stupid letters, I know. I'd like math if it wasn't for letters, right? Mr. Rao has a joke. Mr. Rao has a joke somebody told him. I don't know if somebody really told him, if he just made it up or not, but about I was really good at math until they started putting letters in it. But the letters aren't really letters. What do the letters stand for? Numbers. Stand for numbers anyway, right? So yeah, they're just numbers that you don't know. All right, so here we go. This is J. Is that on the screen? Yep. Oh, it's the other class that it goes off the screen. This is M, and this is L. So here's what they're going to tell you. They tell you that this is a rectangle. In fact, they say this. They put rectangle JKLM. All right, so they tell you it's a rectangle. They didn't put any right angle things in here, but they didn't have to. Why? Because they told you it was a rectangle. Agreed? See that? So they tell you it's a rectangle. So what do we know about a rectangle? Well, we know we got all 90-degree angles. We know the the diagonals bisect each other, and we know the diagonals are what? We just learned it a second ago. They're equal to each other, they're congruent. Okay. So here's what they tell you. They say find MN. So find MN. It's kind of what we did before, but they're going to tell you some stuff. They tell you that JL is equal to 5x plus 2. I used to teach a girl years ago, and her name was JL. Every time I say JL, I think about her. KM is equal to 7x minus 6. All right, here we go. So this is what we're trying to do. What are we trying to do? Find what? MN. We want to find that length right there. Okay? Everybody see it? So what do they tell us? They tell us what JL is equal to. Well, where's JL? From here to here. So that's a diagonal. Agreed? All right. What else do they tell you? KM. Well, what is KM? That's also a what? Diagonal. All right. So what did we just learn about the diagonals of a rectangle? That they're equal to each other. Okay. So guess what you're going to do with this and this? Set them equal to each other. Not the first time we've done that this year. We've probably done this 100 times, haven't we? Set stuff equal to each other. All right. So let's do it. Let's set them equal to each other. 7x minus 6 equals 5x plus 2. Let's do the algebra. You guys should be really quick on this algebra. We've done this a bunch of times. Let's just do a little bit of this in our head. Can we subtract the 5x in our head? Subtract the 5x, subtract the 5x. What do we get? 2x. And then what are we going to do? Add a 6 to 2, and you're going to get 8. Can you do that much in your head at this point? You should be able to. If not, write it down. Put minus 5x, put plus 6 and plus 6. Okay? And there you go. And now you divide by 2. You could do that in your head now if you want to, but I'll show the step. Divide by 2. So what's x? It's 4. But that's not what they ask for, is it? They ask for mn. So how in the world am I going to do that? I don't even know what mn is equal to. There's no mn here. There's no mn here. I don't know what any numbers are here. How in the world do I find that little bit right there?
Plug it into K and once you get the answer by that, you can just find that too.
Exactly. So watch what we're going to do. Do you hear what he said? We're going to plug it into Km. We're going to find that whole entire diagonal. It's not what we're trying to find in the very end, though, is it? We're trying to find Mn in the very end. So, but we are going to find this whole thing right here because I know that these two are equal to each other. So if I divide it by 2, I've got Mn. So you could put it in JL as well. Absolutely. Okay. But I just said Km because because Mn is part of that diagonal. Would it be easier? Because you got a 5 and a 2 and they're smaller? I guess. You could. Okay. It'll work either way. So you're absolutely right. You could put it into this one. But I tell you what, I'm going to put it into this one just so everybody doesn't get confused because I am trying to find Mn, right? So I'll put it into Km. Is that all right? You can put it into this because, again, it'll be the same exact thing. So let's find what Km is. 7 times 4 minus 6, that's 28. Minus 6 is what? 22. So that's what Km is equal to. But don't circle it because that's not my final answer. We're trying to find Mn. So if Km, this whole entire thing from here to here is 22, what's this little bit right here? It's 11. All right? And so Mn, if you want to, you could just put divide by, actually, I wouldn't do it there. I would go Mn equals 22 divided by 2, which equals 11. All right? That's what I would do. If you're going to show all your work, that's what I would do. So really, that's no harder than anything else we've done this year, is it? I mean, we've done this. Do you remember? I don't know if you remember or not. You remember at the beginning of the year, I said when we first did these things, when you first, set things equal to each other, solve for x, plug it back in. I said we are going to do this over and over and over again, okay? And we have, haven't we? And we're going to continue to do so. That's what geometry is all about, all right? At least high school geometry. It's all about taking our geometry, turning it into a what? Just circle, right? Put it into an equation, right? An algebra equation, solving for x, and then plugging it back into something, all right? You should be used to that by now. Do you agree?
Yeah.
I think at the beginning you guys really struggled with that concept, but now I think for the most part, we've got it down. And it's just now we're just doing it to different stuff. That's all we're doing. We're doing the same kind of idea. We're just doing it to different figures. And that's what the whole year is basically all about. Okay, let's do some more. Now we're going to go to rhombus. Because remember what the title of the lesson was? Rectangles, then what? Rhombus, then a rhombi, and then squares. So let's do a rhombus. And then I'm going to angle it a little bit. Transform, shear. Let's go like 10 degrees. Let's go 20. That's good enough. Okay, so there's a rhombus. All four sides are equal to each other. It's not a rectangle because all four angles are not right angles, but it is a rhombus because all four sides are equal. So what I'm going to do is, tell you what, tired just all black and whites, add a little splash of color. Actually, it didn't do it. It's probably because I didn't unclick the box to begin with. Now let's try it. There we go. There's our splash of color. So I'm going to draw the diagonals. And so we got another theorem. Let's see what's true about the diagonals of this rhombus. Now, we know a rhombus is a parallelogram, and we know that the diagonals of a parallelogram bisect each other. So we at least know that, right? So this and this are equal. This one right here and this one right here are equal. But here's what this theorem says. So this theorem, again, I'm not going to write it down, but you can write it down if you want. It says each diagonal of a rhombus bisects two opposite angles. I'm going to take this back to where it was, more in the middle. Okay, what did I just say? The diagonals do what? They bisect the opposite angles. All right, so let's take a look. Here's this diagonal right here. Let's just give it A, B, C, D. And I tell you what, we can name this angle 1, name this angle 2. Instead of calling it ADB, and that gets really confused, right? It's like alphabet soup or something. All right, let's go 3 and 4. Let's go 5 and 6. And let's go 13 and 14. No, I'm not kidding. Let's go 7 and 8. All right. So now, what does the theorem say? It says the diagonals of the rhombus bisect two opposite angles. All right. So look at BD. That's a diagonal. It bisects the opposite angles. So tell me some things that are probably true about this. What can you determine? If this angle right here, angle D, was bisected, tell me something about 1 and 2. They're equal to each other. Exactly right. So now, if this is a rhombus, remember, all four sides have to be equal. Okay, it has to be a rhombus. So if it's a rhombus, the diagonals, what do? They bisect each of those opposite angles right there. So that means angle 1, talk to me, is equal to angle 2. What else do you know? Angle, well, let's do this angle B. We'll use that same diagonal right here. So angle what? 5 must equal angle 6. You with me? Okay. What's another thing we learned about the opposite angles of a parallelogram? We learned this earlier. What's true about the opposite angles of a parallelogram? Anybody remember? They're equal to each other. Okay. So let's take a look at this one step further. So if this big angle right here is equal to this big angle right there, let's just make up a number. Let's say 60 degrees, just make it easy, okay? So let's say both of the angle B is 60 degrees, angle D is 60 degrees. What's angle 1? It's 30, right? Because you split it in half because they're both exactly the same, right? And it makes up that big angle. So that's 30. What's angle 2? That's 30. Well, what about 5 and 6? It's the same. They're 30. 30 and 30. Agreed? So angle 1's not just equal to angle 2. Angle 1's also equal to what else? Angle 5 and angle 6. You see that? So all these are equal to each other. So I could do this if I wanted to. Let's put it up here like that. And what could I do in between those? Put an equal sign. So all of those would actually be equal to each other. So that's kind of interesting, isn't it? All right. This only happens when you have a what? A rhombus. Okay. If it's just a parallelogram, a normal parallelogram, okay, it's not true. If it's a rectangle, it's not true. What if it was a square? Makai, what'd you say? On a rectangle? Yeah, but they have something in common, though. Yeah, they all. So a square is a rhombus. So if this is true about a rhombus, is it true about a square?
No.
But a rhombus or a square is a rhombus.
It's true, but it would be a different.
It doesn't matter. But is a square a rhombus? But is a square a rhombus? Is a square a rhombus? Does a square have all 4 equal sides? Does a rhombus have 4 equal sides? Is a square a rhombus? Yes, it is. Okay. It doesn't mean every rhombus is a square. Listen. It doesn't mean every rhombus is a square, but every square is a what? Is a rhombus. Okay. So if this is true on a rhombus, is it also true? Listen. I'm ready for my last exciting point right here. Shh. Stop. So if this is true about a rhombus, is it also true about a square? Yes. Everything that's true about a rhombus is also true about a square. Because why? Because a square is a rhombus. Okay? You with me? Okay. Trent.
What I was going to say was, if they bisect a square, then all the sides would be, all the angles would be equal.
And what would they be?
They would all be equal.
They'd be all 45. Exactly right. So if this was a square, right, then the diagonals actually bisect the 90-degree angle. So each angle in there from those diagonals are 45 degrees. Exactly right. See, now we're thinking. So tell me something else is true. Now, does that mean this whole angle B and this whole angle A are equal? No. So all those purple angles, all those numbered purple angles right there are not necessarily equal to each other, are they? All right. Now, if it was a square, they would be. They'd all be 45. But what about this one right here? What about this angle? This angle right here is equal to this angle right here. So what could I write here? Angle 3 must equal what? The one right next to it. Anybody going to say it? Everybody scared? Angle 3 is equal to angle 4. Okay? And that should also equal what? Angle 7 and angle 8. All right? Because again, if this was 60, then what would angle A be? If this whole big angle B was 60 degrees, what's this whole big angle A? 120. How'd you get that? Took it away from 180, right? Because they are they're supplementary, right? They're consecutive angles, so they're supplementary, okay? So this would be 120. So what would angle 3 be equal to then? Be 60. Angle 4 would be what? 60. Well, this is 120, so angle 7 must be what? 60, and angle 8 must be 60. You see that? All right. We're learning, aren't we? Isn't that fun? All right, good. Let's do another thing. Let's do another thing. I'll just keep the same picture right here, but we've got another theorem. So here's a second theorem about this rhombus. Okay? So here's another theorem. Check this out. Do you see the yellow diagonals right there? I'll go back to yellow. Keep it color coordinated here. Look at the angle that's formed by those two yellow ones. What does it kind of look like? Like if I kind of turned it like that, What would this angle right here be? What does it look like it could be? Well, the angle itself. It's a right angle. This angle right here, okay, is going to be a right angle. When is that true? That's a weird looking right angle. Boom, boom. There we go. It's a little better. So that right there is a right angle. So what does the theorem say? It says the diagonals of a rhombus are, give me a good geometry word. If it forms a right angle, then the lines are, the two diagonals are, if they make a right angle, say it, you said it. They're perpendicular. See, he's been away for a year and a half, okay? Seems like it. So it's perpendicular to each other, right? So these diagonals, that's what this theorem says right here. If you want to write it down, you can. The diagonals of a rhombus, again, this doesn't happen with every parallelogram or every quadrilateral. It only happens when it's a rhombus, but the diagonals are perpendicular. Everybody with me? All right, so they form a right angle. And that could help you find some of these. Remember we did that 60 and 120 thing? Let's just see if that works. Remember we said if this was 60 degrees, this angle right here would be what? 30. We said if this whole thing was 60, this would be 120, which means angle 4 would be what? 60. Does that work? It does work, doesn't it? You see that? Because look, 60 and 30 is what? 90, and 90 is 180. So this has to be 90 degrees. It is cool. See how it all comes together? All right. Yeah, that's right. Because I've got, now because you couldn't add this, right? You're just adding these right here and these here, these here, and these here. You're not going to add that 90 to it, but yeah. All right, we good? Oh, by the way, let's do this. We could say this, that AC is perpendicular to BD. That's it. I need to write that. So you don't have to write out the whole theorem, but that basically explains the theorem, okay, that the diagonals are perpendicular. Ready for one more? Let's do an example. And then we should be able to finish with the example. There's still a few more things we got to cover on this, but I think it'd be good to finish with an example. Let's actually copy this. And we'll paste it. So we'll use that same. And this is ABCD again. And we need some diagonals. Now, they're going to tell you some stuff, and you have to figure out what's missing. Now, this time they don't use the letters, okay? They just put numbers in here. Makes it a little bit easier for you. Let's change that color to pink. All right, so here we go. It's a rhombus. So if it's a rhombus, what do we know about all four sides? They're all equal. Okay, so you got all four sides equal, so you know it's a rhombus. And what's true about this angle right here in the middle? If this is a rhombus, the diagonals make a what kind of an angle? Right angle. We just talked about it. Okay. Now here's what they're going to tell you. They're going to tell you that this right here is 34 degrees. That's a 4. Doesn't look like it. Let's make it look more like a 4. There we go. That's a little better. Okay, that's 34 degrees, and that's it. But they number some angles. They call this angle 1. They call this one angle 3. They call this angle 2. And they call this one angle 4. It doesn't mean it's 2 degrees, 4 degrees, 3 degrees, okay? It's just that's the name of the angle. This, that's a right angle. Okay, that's a right angle. Okay? So here's what they're going to ask you. They're going to ask you some questions. Let's go back to white again. It's a little easier to read. So part A says, what is angle 1? Part B, some of these you might just be able to look at it and tell. But some of them you got to do a little bit of math. Angle B, they ask for angle, or number B, or whatever it is, letter B, they ask for angle 2. Letter C, they asked for angle BAD. So I guess they didn't number that one. Then part D, they asked for angle 3. Part E, they got a lot of parts to this. Angle ABC. And then part F, it's angle 4. Okay. Number 1, or letter A, is the easiest one. Angle 1. Just looking at it. What's angle 1 going to be? I mean, technically, you could do a little math, but what's angle 1? Yeah, I'm sorry. It doesn't show up very well here. This is a right angle. This is angle 1 right here. So what's this angle going to be? It's going to be 90 degrees, yeah, because this is a right angle. If it's right next to it, right, it's supplementary. So it's 90 degrees as well. So angle 1, that's easy. I just basically look at it. I mean, technically, what math did we do? Technically, we went 180 minus 90, didn't we? Because it forms a straight line, right? Forms a straight line. This angle's 90, and you take it away from 180, you get 90. That was easy. What about angle 2? Angle 2 is super easy. We just went over it. What do these diagonals do to the angle? What do they do to the angle? On a rhombus. This is a rhombus. They bisect the angles. So that means if this is 34, what's angle 2? It's 34 as well, right? Because it's bisected. Because it splits this angle into 2 equal angles, right? Were you guys here for this lesson? Yeah, it was like 10 minutes ago, all right? So these 2 angles right here are equal to each other. So if this is 34 degrees, then what's this? It's 34 degrees. On that quiz I passed back to you guys, I saw some of those problems were so easy that all you had to do was just look at it. Like that one with that 120, I think, on there. Remember that one? All you had to do was say, if that's 120, the other one's 120. We even went over that the day before we took the quiz. Anyway, so you got to get these easy ones. Let's finish up. BAD. BAD. That's this big one right here. Okay? Now watch. I'll do it quick since we're running out of time. If this is 34, this is 34. What's this whole big angle right there? 68. So what's this big old angle right here? It's 68 degrees. Because the opposite angles are equal. Angle 3. So if the whole big angle is 68, what's that angle 3? It's 34. Okay? You could go alternate interior angles, right? 2 parallel lines cut by transversal, all that stuff. ABC. Let's find out that whole ABC, this big old angle right there. So how would I find it? Let's hang on just a sec. How would I find that whole big angle B? If this is 68, how do I find this? It's 180 minus 68. Okay, which would be what? 112, is that right? Okay, so that's 112. One more, angle 4. What's that one right there? If that whole thing's 112, what do we do? Take 112 and do what to it? Divided by 2, and that is 56. Okay? That's how you do that stuff. Your homework is number 1 through 11. And it's on the work or the lesson plan thing. It's section 6.4. It's not on RenWeb, but it's on the it's on that slip I gave you. It's section 4. Yep, we're up to date and everything. All right, you too.